Now, what I want to tell you about right here is these quirky electronics here. You know, right here. I was talking about this this one thing. In 1988, there was the dealership where I was working purchased this AMC Renault franchise. And what they did was they brought one of the first vehicles I checked when we first got that franchise was an 81 Renault 18i. Now you probably haven't ever seen an 81 Renault 18i because there's just not very many of them around out there. And this thing had Bosch fuel injection on it, and the engine controller was so primitive that you could buy just about any part that it needed in a radio shack. That's how old that engine controller was. You couldn't buy the circuit board or the housing. But what I'm saying is most of the parts of it were just plain old electronic parts. But anyway, that thing was this car, in my mind, and all you've ever seen this before, was probably worth $200 running. You know what I'm saying? What is it? It was a little station wagon sedan. It was a Renault, you know, and it was an 81 model, you know. Now, this was in 1988, so it wasn't really all that old, but it was just a kind of a funny car. All right, so what happened was they needed, first they didn't have any spark, and I found out that the thing that was really interesting, little GM ignition module mounted on a little heat sink there, and they used that to fire the pump. Well, I found that was bad, and I just put one of those on there, and I had spark, but then I did the fuel injection. When I looked under the seat where the engine controller was, you could smell it. It burned up because it had been wet. So I took it out of there and opened it up, and it was just all fried on the inside. And I said, well, they're never going to pay to have this car fixed. You know, this is really not worth that money. That engine controller was $1,700. And whenever we called them and told them it was $1,700, they said, go ahead and do it. So we put the engine controller on it, got it running. The guy, I don't know if he's still driving it or not. But the fact was, this particular one, I'm going to show you this right here. This is crazy as all get out. This thing right here, back years ago, when I first went to General Motors School in 1981 over there, the instructor, somebody says, well, how will this car run if that computer quits running? Now, you remember in the early 80s when they first put carburetors on cars, feedback carburetors that could get oxygen sensor input to the computer, and it would change the mixture, one of the carburetor and all that. And they got a little solenoid in there that would go tick, 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 and then the carburetor. Well, somebody says, what if this stuff doesn't work? She unplugged the engine controller and started the car. In those days, it would work. And they said, well, what if the car gets a lot of miles on it? She says, if you maintain it right, it runs like a brand new car the whole life. You know, if you start disconnecting things and kind of modify it, you're going to have trouble. But anyway, the point is, this one here is a car, a 95 Eagle Talon, that came over here as a no start. And this is the kind of stuff you run into when you get in the top tier of drivability and stuff. And this is the kind of stuff Michael eats for lunch over there. So this thing came in here and it wouldn't start, and they had nobody else had touched it. This was the first place she brought it. She lived right over here, and her daughter was enrolled out here, so she brought it out here, and sure enough, no. So it spins over. So what do you do first? What's the first thing you do whenever one don't start? You're going to check for spark and that kind of thing. We had no fuel injection. We had no, nothing the computer was supposed to be doing was it doing. On this particular one, you got a 9-volt feed going to your speed sensors, like your crank sensor and your cam sensor. You got a 9-volt wire going to them. And on the rest of the sensors, like the throttle position sensor and these other ones, you got, if it's a 3-wire sensor, it'll have 5 volts going to it. If it's like a TP sensor or maybe this, DPFE on there or whatever. So we had no 5 volts, we had no 9 volts. Now I don't know what happened to the 5 volts and the 9 volts, but we had power and ground going to the controller. You get it? You got your computer, you got power and ground going to the computer. It's supposed to be putting out the 5 and the 9 volts, but it's not doing it. So then you say, well, since it's fired up, but it's not doing what it's supposed to be, then we got engine controller issues. So we ordered an engine controller. It was $210. Well, not that much. You'd be surprised. From the dealer. Brought it in here. The students plugged it in. It was sitting right down there by where the air compressors are. Plugged it in, fired the car up, drove it up here. It ran for about 20 minutes, and we were going to, make sure everything was okay, and it died. And we went out here and checked it, and it had fried that engine controller. Now that's bad news, isn't it? How are you going to find out what cooked the engine controller? You got to remember now, after this has happened, it won't talk to the scan tool or anything. Well, you're dead in the water. Now you're going to buy another $200 engine controller, see if it'll fry that one, or see if you can catch it frying it. You see, you see what I'm saying? How dicey that is?
That's what
you will see this kind of stuff. This is not funny. But at the same time, you got to just sort of take the challenge as it comes, you know. I mean, sometimes you got to scramble around trying to figure out what's going on, and that's what we do. All right. This one here, I happen to have a $9,000 pod out here that I bought called a dynamic data collector, and it's made by Sun, but Snap-on was marketing it at the time. All right. And so what I had was this situation here. I plugged that thing out. I ordered a cable that would go between the engine controller and the wire harness, and I plugged that in between the engine controller and the wire harness. And you could do what's called a sweep test, where it checks, first it checks ohms on everything, and then it checks volts on everything. And anything that's out of line with what it's supposed to be, it lights it up in red. And so the first thing it told me when I ran through that procedure on that machine was that it lit it up, and I can show you what those screens look like. Let me go up here. See, that's what the screen looks like on that dynamic data collector. And, you know, they did these tests and this kind of thing, and then did all these pins. But we didn't have anything here in the way of reference voltage, basically. That's what it amounted to. And, you know, I don't go into a lot of deal on that. But I said, well, I got that Dodge Neon, this little red one out here, and I said, I'm going to plug that Dodge Neon in. That engine controller's just got one wire that's different, and it's got to do with the transmission. And I'm not even going to crank the car. I'm just going to do a sweep test with my engine controller plugged in. You know what I mean? And so, worst case scenario, I had to get my engine controller rebuilt and burn that one up. You know what I mean? But, and it didn't burn it up right away. I thought it did too. Whenever it burnt that other one up. So we turned it on, did the sweep test, and it told me the throttle position sensor was bad, was shorted. I've never, before or since, seen a throttle position sensor destroy an engine controller. I didn't think it was possible, but that one did. $85 throttle position sensor, put it on there. Got another engine controller, put it on there, and we were sailing. And she drove it until it started knocking because they ran it out of oil. You know, that was like 3 or 4 years later. That's that one there. All right, now here's another little thing. This is the kind of crud you run into. Look at this. Look at these scope patterns. That same machine I was using for a scope, but you can use it for a scope. This is what the normal injector pulse is supposed to look like. This is on a different car. This is a story that if I don't tell you, I'm going to forget it. It's really important. This was an 86 Pontiac Grand Prix, I think. Little V6. All right. Her cousin put an intake gasket on it, and it was skipping. And so we got out here and we found out it's skipping on cylinder number 1. All right. So we put on our stethoscope. We listen to the injectors, and the number 1 injector sounds. The rest of them have got crisp, sharp, click, 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 click noises. Right. The number 1's going barely making any noise at all. And so pull the thing off and say, well, there's something going on with this injector. So put another injector in there, just like it would. Doesn't change. So then I get the scope pattern. This is the signal I was getting, and the timestamp is the same now. This is see I got right here. All of this was the same. Remember how you know in your scope how you've got to have your voltage and your time and all that set up. It was set up exactly the same way both of these. That one injector that was cluck cluck cluck, it had a pulse width that was very very narrow, like this right here. Instead of having a nice wide one, let me turn it off so you can see it. Had a really narrow one, and about that. Did you know that I got an engine controller? I mean, I actually measured the continuity of the wire, make sure nothing was shorted, measured the injector, make sure it didn't have too little resistance on the coil, and all that. All of that stuff was great. Got another engine controller from the salvage yard for $20 because the car was old. You could take a back engine controller from those. $20. Put it in there, did the same thing. Put a second one in there, same thing. He just gave me the second one. Finally, I said, you know what I'm going to do? I'm going to go ahead, because these injectors fire sequentially, right? They follow the firing order. And they got each one of them's got a separate driver on a computer. But even if they fire together, a couple fire, it doesn't matter because the fuel's just being stored for a second anyway. That Bronco wire fires them in banks. It fires these two and these two and these two and these two. See? I mean, it still runs just fine. And so I took the Scotch lock, which I don't like Scotch locks, but for a small current, low current load, it's not a problem. And that Scotch locked the injector that was hitting right together with that one right there, and that car ran great. And I said, what's the worst case scenario? Said, we fry this engine controller. Well, we got a stack of them darn things now. We got 2 or 3 of them out here. And I told the girl, I said, drive this thing. She was driving a Delville back to go to school. And this thing never misfired again. Now, I've been in schools where there were General Motors engineers and all this kind of stuff. I have no clue. Never figured that sucker out. I'm going to be honest with you. Sometimes you're going to run into one that's going to... If, you know, the car is running smooth, I didn't fix it like it should have been. It was an old car. How much time do you want to spend? You know what I'm saying? So basically, I got the thing running right, and when I was talking to the General Motors engineer, he says, you didn't hurt anything because his injector drivers will carry about 4 amps, and you're only pulling 0.8 of an amp per injector, and you're only like 1.6. You got it? See where I'm pulling at? It doesn't make any sense. Why would one injector have a very narrow pulse width, and all of them are supposed to be operating the same, huh?
Was the wire corroded?
No, we did all that stuff. I mean, I even did an overlay on the wire harness. It didn't change the whole thing. But anyway, that was one for the unit back there. So, and now, see, the thing about it is, if I was going to be, if I was going to get all right, now here's another one. I will show you another one right here. This is the kind of stuff that you're probably not going to get it anywhere else. I've got a bunch of stuff in here. Not that one, not that one, not that one, not that one, not that one. This one. That's the one I'm looking at right there. Scan tools, oscilloscopes, and toothpicks. Got it? Okay, here's the scan tools, oscilloscopes. Let me tell you about this Cherokee. We're driving this Cherokee, and whenever we're driving the Cherokee, it starts skipping. And it's running really lousy. Switch it off, restart it, runs good okay for a while, and then it starts skipping again. All right, so what I found out was, all right, Wes, look at me and put that phone away. What you got here is you got a situation where you're dropping companion cylinders. Now, what's companion cylinders? What are the companion cylinders on an inline straight 6? Anybody know? Companion cylinders are the ones that come up and down together. One on compression, one on exhaust. Okay, what's the firing order on a straight 6? No. 15, 36, 24. You remember that? Straight 6 typically got a 15, 36, 24 firing order. These crass guys that, are got gutter brains, they say when you're thinking about the girl you're wanting to date, too young, too old, just right. That's how you remember that, 15, 36, 24. All right, that's what they said. I didn't come up with that. But that's a sort of memory bug. See, 15, 36, 24. All right, so that's the firing order. Now, tell me again. Well, the companion cylinders are 1 and 6, right? And then there are the 2 middle ones, which is 3 and 4, and then you got 2 and 5. Every time this thing dropped cylinders, it was always dropping a companion pair. Got it? Now this thing got a coil rail, like my yellow Jeep. It's just a long coil rail that's got 3 coils in it, and all that. And there, it's all wired up inside that coil, so it fires these things. It's firing the companion cylinders at the same time. Pop, 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 pop. So I'm thinking. Furthermore, listen to this. This is cool. It's throwing me a fault for ignition coil primaries, meaning the little trigger wires that fire the coils. It's throwing me a fault for those. All right, so I'm saying, well, there must be something wrong because the engine controller knows more than I do, right? So it's trying to point me in the direction of the ignition coil primaries. Now, there was a guy that had a Grand Cherokee in his shop that Jerry Truglia, who's a world-class instructor that teaches for, Max and Motor Age and everybody else, and I know the guy. But anyway, this one guy had a car in his shop, and Jerry went over to help him, and he had that car in that Grand Cherokee in his shop doing the same thing for 6 months. And he had split all the wire harnesses, and it was a mess. It looked like that stuff on the floor out there. Biggest mess you ever saw. He was trying to figure out why this thing was doing this. And he kept trying to focus on ignition coils. He felt like this was wrong, that was wrong, whatever. All right, and so I cut the coil rail off of it, and I took a coil pack like the one on my ignition board out there, like on a Ford, and it had a connector plugged in, and I wired that sucker up to fire the plug. I put spark plug wires on it and all that kind of stuff, just set it on the fender over, and we fired that thing up and drove it. And it did the same thing with a whole different coil setup on it and all that kind of stuff. And so I wrestled with it for a while, and I pulled scope pattern. Look at it. So now this right here, I'm getting cam and crank signals right here. These are the cam and crank counter graphs that fed to the scan tool by the PCM, and it seemed like a double trace. That was rapidly moving lines, on the photo. But anyway, it compresses the data, and I was working. You're working with this, trying to figure out what it's supposed to look like. The long and the short of it is, if you don't know what it's supposed to look like, you're probably not going to recognize it whenever you see anything wrong. Now this is crazy right here. See, graph number 2 is a current round picture of what the PCM was doing with one of the primary circuits, and the bottom traces the cam signal. And somebody is really trying to call me, and I need to see who it is. Hello. Hey. Uh-huh. It looks like I wanted the round white can. Right? That was the first guy. Okay, now then. So anyway, long and the short of this, I got down here, and what we found out was, you see this scope pattern on the very bottom? I did this with this other scope. This is what that, now listen to this, Wes. Pay attention, because you're probably going to run into this one day. The cam sensor is adjustable on these. It's down there where the distributor would order. Kind of like on this engine here. And you're actually going to turn that thing, and it's got to be in the right spot. Got it? All right, this one here, this is the crank signal, which has got 4 little windows. That's the cam sensor, and that cam sensor is supposed to be making its cut halfway between 2 of these sets of 4. Got it? All right. Whenever I first saw it, it was making its cut right here. And so I went ahead and adjusted that, and when I got it adjusted, all of that went away. See what I mean? Now, there's not, let me quantify this. It's not like that on every single vehicle, but the cam sensor signal is important. I will tell you that on some vehicles, you can unplug the cam sensor and it'll run just fine. On some other, it's on 340 code, PL340. But on some other ones, if you unplug the cam sensor, it may start and it may not. An Altima, like that black one you worked on, put that motor in, is like that. And sometimes you'll have a signal that will be out of line here where there's no adjustment on the cam sensor, and you may unplug the cam sensor and it may start this time, may not start next time. But if the cam sensor and the crank sensor are out of line and it's reading off of little toothed wheels on the cam and the crank, what does that typically mean? That means that it's out of time, don't it? Yeah. All right, well, if you know it's not out of time, but it's still reading wrong, I found out you put a cam sensor on it. You may have a cam sensor that's causing that signal to read wrong. I never would have expected that, but I saw that on that black car. The cam sensor was reading when I put my scope on it like it was out of time, but it wasn't out of time. Anyway, this one here, that took care of that, you see. And that's what the cam sensor looks like. But the long and the short of it was, see, there's that little deal I told you about up there at the top where I wired up the other coil to make it fire. And look, it was firing screwed up patterns. It's supposed to look like this. It looked like that. See? There's the cam sensor down there. And on that Jeep, you can turn that thing, you can put it on top dead center 0. Got to be on top dead center compression on number 1. Dead on 0, you got to mark down on your balancer. And then over here on the side of the motor, real easy to get to, you're supposed to be able to stick something through the hole in the outside shell and the hole in the inside. Now, I had a little piece of wire that I use, but you can do it with a toothpick. And that's if you don't have all the oscilloscope and the fancy equipment and all that, if you can get that sucker where you know it's on top dead center compression, by puffing your rag out or whatever and then bring it on up real slow, you can adjust that cam sensor on one of these Jeeps by putting it right there. By putting it so that you can stick something through that hole and then locking it down. Now, that's why I named the article Scan Tools, O-Scopes, and Toothpicks. Because I spent a week trying to figure that sucker out, and I could have fixed it with a toothpick in 5 minutes. See where I'm going with that? That's why I call it that. There's a guru named Mac Vandenbrink that I was talking about the other day that knows all about the scopes and everything, and he read this article in Motor Age, and he sent me a copy of his piece of his training material, a little complimentary, sample copy of it, and a toothpick. So, anyway. All right, now that's the end of that today. We'll turn that off, and we'll get up here. All right, that's the only